Hi, I am Beatriz, a data visualization engineer at Fidzai, and I am going to talk about our work, Show Me What's Wrong, combining charts and text to guide data analysis. But before going into the details of our work, I will first talk about the use case to which it's applied, which is financial fraud. And just by looking at the news, you can get an understanding of how much money people are losing of their savings because of fraud, and how much money banks are having to refund people because of fraud. So it's safe to say that financial fraud can significantly impact people's lives, and thus that this is an issue that needs to be tackled. And how are banks currently dealing with this? Imagine that you are buying a pair of sneakers. Chances are that your transaction will go through a system that, combining machine learning and rules, will automatically classify a transaction as either not fraudulent or as fraudulent. But there are some cases where the system is not sure of the classification of your transaction, and in those cases it will generate an alert, which means that a person, a fraud analyst, will need to manually review the data and classify the transaction. And how do they currently review this data? First, they look at some details about the alerted transaction, such as its date, location, and amount. They also look at some details about the person who made the transaction, like their name, date of birth, and address. After that, they will compare the alert with past transactions of the person. They will look at the table with all the past transactions of the person, and they will scroll through it to assess patterns. Then, they will, for example, look at the location of the alert and compare it with all the other locations of past transactions of the person to assess if this location seems to make sense. Or they will look at the amount of the alert and compare it with all the other amounts of past transactions of the person to assess if this amount seems to make sense. They do all of this just by looking at tabular data, and they must do all of this in just around 1 minute. That's all the time that they have to perform these tasks. So it's safe to say that this is overwhelming and that they need a new system to evaluate this data. And that's why we are proposing our system that combines charts and text to guide the analysis. Our system is composed of 3 regions that give different levels of detail of the information. The first region helps analysts detect suspicious areas. The second region helps them understand those areas broadly, and the third one lets them explore those areas in detail. I am now going to explain each of these regions, and I will start by the first one, the knowledge area console. This is the starting point of the analysis for analysts using our interface. Here, each area of the analysis is represented through icons, for example, the person who made the transaction, the location where the transaction was made, and the card used. Here, areas of the data that might require more attention are highlighted using red and a circle. Here, this area is red and with a circle because it might require more attention. And here, analysts can select areas that will be analyzed in the other interface regions. Each area is an icon which is clickable, and clicking in an icon means that this area is being selected. In this case, this one is a selected one. After selecting an area, analysts will then look at the knowledge area text summary. This is an LLM-generated summary of the insights of the selection, where the most relevant information about an area is highlighted using bold. Risky information is pointed using, once again, the red color. If, after reading the text summary, analysts still feel like they need some more piece of information or that they want to confirm some data, they will then look at the knowledge area graphical representation. There is a graphical representation for each knowledge area, and here all the data points that compose an area are represented, enabling analysts to perform an exhaustive evaluation of the data and to confirm insights that were given in the other interface regions. So, once again, this is the system that we are proposing, combining charts and text to guide the analysis. Our next step was to understand how this system impacts the analysis. For this, we showed it to 7 fraud analysts, and the feedback was actually pretty good. They stated that this approach would improve their efficiency, stating that in a matter of just 2 seconds, they were able to understand what the data was showing them. They praised the tool's capabilities in conveying behavioral patterns, saying that they can easily get an overview of the behaviors of the alerted person, and they stated that the interface effectively points to areas with potentially risky information, saying that with this interface, it's easier for them to identify what is wrong or what is not common to the person's activity. Which is great, this is exactly what we wanted to improve in the analysis, but there's still some work that needs to be done. First, we need to adjust the graphical representation of some knowledge areas to simpler and more commonly used graphs, especially since analysts are not used to evaluating data through graphs. We also want to perform usability tests to quantitatively measure our interface. And we want to test the usage of ML models for the risk assessment of the data. Right now, we are just using rules, and we want to leverage that. And that's it. Thank you so much. If you want to know more details about our work, please don't forget to check our paper. And thank you again.